Hello students, welcome to my channel CM Hub, where you, me and chemistry connect with each other. This platform is a gateway for mastering chemistry. In the previous episode, we discussed one problem on chemical equilibrium, where we discussed the relationship between the reaction quotient Q and the equilibrium constant. We understood that if Q is equal to equilibrium constant, then the reaction establishes equilibrium, and if Q is greater than Kc, the reaction proceeds in the backward direction, and if Q is less than Kc, the reaction proceeds in the forward direction. Now, this is another question which was asked in 2024 NEET examination. The question is, in which of the following equilibria Kp and Kc are not equal? So here the question is based on the equilibrium constant but calculated under two different conditions. Kp refers to the equilibrium constant when the components are in gaseous state and their partial pressures are taken for calculation. And Kc represents the equilibrium constant when the composition of the reaction mixture is expressed in the active masses or the molar concentration. Now, he has given four equations. To know the answer, we need to first know the relationship between Kp and Kc. Kp is equal to Kc into RT to the power delta N, where Kp is the equilibrium constant when the components are expressed in terms of the partial pressures, and Kc is the equilibrium constant when the components are expressed in terms of active masses, that is nothing but the molar concentrations. Now, what is R? R is gas constant, T is the absolute temperature, and delta N is the difference between, this is the important one. Delta N is nothing but the difference between number of moles of gaseous products, number of moles of the gaseous reactants. Let us look at the calculation here itself. Here, let us first find out delta N. What is the number of moles of PCl3? 1. Number of moles of Cl2? 1. So number of gaseous products are 2. And what are the number of gaseous reactants? 1. So here delta N is equal to 1. In the next case, what is delta N? Delta N is number of gaseous products are 2. Number of gaseous reactants are 1 plus 1, 2. So 2 minus 2, that is equal to 0. In the third case, delta N is equal to, now here it is 1 plus 1, 2 gaseous products, and here 1 plus 1, 2 gaseous reactants. So here also 2 minus 2, 0. Now let us look at the last option, 1 plus 1, 2 gaseous products plus 2 gaseous reactants. Here delta N is equal to 2 minus 2, that is equal to 0. Now what is the question asked? In which of the following equilibria Kp and Kc are not equal? So now let us again go back to the equation. Kp is equal to Kc into RT to the power delta N. Case 1. If delta N is equal to 0, then Kp is equal to Kc. Case 2. If delta N is greater than 1, then Kp is greater than Kc. Case 3. If delta N is less than 1, then Kp is less than Kc. So now only in the first case Kp becomes equal to Kc when delta N is equal to 0. If delta N is not equal to 0, then Kp cannot be equal to Kc. So now directly look at the question. Kp and Kc are not equal. Kp and Kc will not be equal when delta N is not equal to 0. So in this case delta n is equal to 1. So this is the option 1 where Kp and Kc are not equal. In all the remaining cases delta n is 0. So if delta n is equal to 0, what does it imply? Kp is equal to Kc. So these are the three conditions that you need to remember. Delta n, which is nothing but the difference between the number of moles of gaseous products and the gaseous reactants. If equal to 0, Kp is equal to Kc. Delta n greater than 1, Kp is greater than Kc. If delta n less than 1, Kp is less than Kc. The question can also be asked in terms of a problem. You will be given a Kc value. You will be given a Kc value and you are asked to find out Kp at a given temperature. Or you will be given Kp and you are asked to find out Kc at a given temperature. In such case, you need to know the value of R. The value of R you learnt in the chapter of gaseous state depends upon the units of measurement. R value is equal to 8.314 joules. Whenever the value is expressed in terms of joules, our R value is 8.314 into 10 to the power of 7 ergs, or R value is 2 calories, or R value is 0.0821 liter atmosphere per Kelvin mole. This also is joule per Kelvin mole. This also is erg per Kelvin mole. This is also calorie per Kelvin mole. There is another one called as Boltzmann constant, which is nothing but the ratio of R by N, where R is nothing but gas constant and N is nothing but Avogadro number. There we say that the value of K, which is called as Boltz's constant, is per Kelvin molecule. So I hope you understood the relationship between Kp and Kc, and also if problem is asked how to take the value of R, and temperature should always be in Kelvin square, that is T degrees centigrade plus 273. That's all for today. Let us come with another interesting question and interesting concept in the next episode. Take care. Bye-bye.